The word semiconductor may sound complex. It is the key to everything from smartphone to self-driving cars. What exactly is semiconductor? In this video, I will deeply explain what is semiconductor is in smart, simple, easy to flow way. Before we dive into semiconductors, there is something important we need to understand first. What makes materials conduct electricity and what makes it stop? Okay, let's look quickly what is conductor and what is insulator. Because the conductivity of semiconductor is in between conductor and insulator. Because of this, if we first understand deeply what is conductor and insulator, we can easily understand what is semiconductor is. What is conductor? Conductor is a material that lets electricity flow through it, just like water flowing through pipe. Do you know? Just like water flowing through pipe, conductor is a material that lets electricity flow through it. So, metal like copper, aluminum are great conductors. Why? Because they have lot of electrons easily move. Because their electrons are free to move easily and they want electricity loves. What is insulator? That is opposite of the conductor. Insulators are materials that block the flow of electricity. Do you understand? If the material blocks the flow of electricity, that material is called insulator. Example, rubber, glass, plastic are examples of insulators. Their electrons are tightly bounded and cannot move. Do you understand what is insulator means? Insulator means materials that block the flow of electricity. After understanding this, let's dive into what is semiconductor is. What is semiconductor? Semiconductors are special materials that lets some electricity pass through, not too much like metal and not fully blocked like rubber. They are right in between. That means it conducts electricity. It is not like conductors. It blocks electricity, but it does not like rubber or like insulators. So it is conductivity and it is non-conductivity. They right in between. That means it has the ability to conduct and it has the ability to block to electric flow, but it does not as much as the conductors to conduct electricity and as much as the insulators to block the electricity. So in between them, it has the ability to conduct and to block, but the ability is in between them. In other point, which means we can control how much electric pass through them. That means by increasing the surrounding temperature or by increasing the temperature, we can control the conductivity of semiconductor, and by increasing or decreasing the amount of impurity we add to semiconductor, we can control how much electricity pass through them. So, and that what makes semiconductor so powerful for electronics. So this property makes semiconductor powerful. Let's discuss what is energy gap is. Energy gap means, do you understand what is energy gap? It is the difference between valence band and conduction bands. In the conductor, there is no gap between the valence band and conduction band because there is no need of energy to become free electron. So because of this, the conduction band and the valence band are overlapped each other. In semiconductor, we have small energy gap between the valence band and conduction band. Because of this, it needs a small amount of energy to jump from the valence band to the conduction band in semiconductor. But in insulator, it have large gaps. Because of this, there is no movement of electron because it needs high energy to move from the valence band to the conduction band. So in insulator, we have a large energy gap. There is no movement of electrons. That means there is no flow of current. There is no flow of electricity. The next, to understand more deeply, we have to understand what is valence electron. Valence electrons are the outermost electrons in the atom. Already we understand that atom consists of electron, proton, and neutron. In the last shell of the electron, we have electrons. The number of electrons affects the property of the materials. So if we understand the number of electrons, we can understand the property of the materials. They determine how atom bounded and how conductive material is. Do you know how many valence electrons in semiconductor? Semiconductors like silicon, germanium, germanium and silicon are the most example of semiconductor. So they have 4 valence electrons. These electrons form strong bonded with numbers. At the room temperature, they makes bonded each other with numbers. With the surrounding electron, it makes bond, and because of this, low conductivity. So the next to understand is how valence electron affects the conductivity and how we can increase the conductivity of semiconductor. At low temperature, electrons are tightly held, and because of this, we have low conductivity of the semiconductor. When give energy or heat, electron can jump from the valence band to the conduction band. Electron can jump from the valence band to the conduction band. Because of this, if it jumps, if the bond is breakdown or the bond is breakdown, it increases the conductivity. So to increase the how to increase conductivity of semiconductor? How to increase conductivity of semiconductor? The first one is by increasing temperature. The second one is by adding impurity. Do you understand? The steps to increase the conductivity of semiconductor. So by increasing the temperature, the first one is by increasing the temperature. The second one is by adding the impurity. The second one is by adding the impurity. That means like phosphorus, boron, aluminum, we can add to the poor semiconductors. If we add, we can increase the conductivity of semiconductors. Okay, what is the effect of temperature in semiconductor? Unlike metals, metal can affect if we increase the temperature, it decreases the conductivity of the metal, or the conductor decreases the conductivity. But in semiconductor, when we increase the temperature, it increases the conductivity in semiconductor. The reason is why more electrons gain energy to jump from the valence band to the conduction band. If they jump from the last shell to the surrounding, they make a free electron and can move easily. If there is movement of electron, means there is flow of current. The next is, do you understand what is doping? Doping means intentionally adding impurity to poor semiconductors. So this changes the electrical behaviors of semiconductor. That means if we dope to the semiconductor, it increases the conductivity of the semiconductor. By doping, we can create 2 types of semiconductor, N-type and P-type semiconductor. N-type semiconductor add 5 valence electron to the poor semiconductor. For example, like phosphorus, if we add to the poor semiconductor silicon, we have extra electron, 1 extra electron, because the phosphorus have 5 electrons in the last shell. The 4 makes bond with the silicon 4 electron, and we have 1 extra electron. From each atom, we have extra electron. If we doped small amount of impurity, that means we have extra electrons, million of electrons. Because of this, it increases the conductivity of semiconductor, and these types of semiconductor we can call N-type semiconductor. The next is P-type semiconductor. If we add 3 valence electron, the elements that have 3 valence electron like boron, aluminum, if we add small amount of boron to the poor semiconductor silicon, we can create P-type semiconductor. It creates holes. Hole means there is shortage of 1 electron from boron to make bond with the silicon atom, but it does not have. So this shortage increases the conductivity of semiconductor. The next one is how we make PN junction. If after forming or after made P-type and N-type semiconductor, if we join together this, they make PN junction. The intersection between P-type and N-type in the middle part, it's called PN junction. By combining this P-type and N-type, we can make diodes, lighting emitting diode, solar cells. We can make also transistors. Number of electronic equipment is the basic of semiconductor is P and N-type semiconductor. Thanks for watching. This is all about today's lesson. Thanks for watching. See you soon.